Okay, let's go ahead and get started. Whoops. Just make sure everyone's in the right room. This is the Exchange Server 2010 High Availability Deep Dive. This is a 400 level session. We're going to be going deep into the inner workings of the database availability group, and we're going to be focusing on 4 primary areas. We're going to talk extensively about database availability group networks. We're going to be talking about a component called Active Manager. We're going to be talking about a process Active Manager does called Best Copy Selection. And we're going to end up with a discussion of data center activation coordination mode. So those are the 4 areas we're going to hit. If you've got questions about those areas, we can take them in the end of the session. If you've got questions about other areas, right after this session, I'm going to go right to the Microsoft Pavilion underneath the white square that says Microsoft, and I'll be hanging there to talk about anything related to Exchange that you want to talk about. But for this session, these are the things that we're talking about, starting with DAG networks. Okay, so just out of curiosity, how many of you are running a DAG today? Awesome, awesome. How many of you are planning to deploy a DAG pretty soon? All right, great. Well, you definitely want to know about DAG networks because it's a new concept that we've introduced in Exchange 2010. We didn't have the DAG in previous versions, so we didn't have anything called DAG networks. In fact, most of the networking in the high availability platform in previous versions was pretty much largely provided to us by the Windows failover clustering component. Since we don't use that component the same way we used to, now we have our own networking constructs, and those objects are simply referred to as DAG networks. So a DAG network is simply nothing more than a collection of subnets. Each DAG network has one or more subnets associated with it. And there are 2 types of DAG networks. One is called a MAPI network. The other is called a replication network. And we chose those names because we wanted them to be pretty self-explanatory. The MAPI network, as you might imagine, is the network over which, for example, MAPI traffic occurs. So traffic from a hub transport server to a mailbox server, traffic from a client access server to a mailbox server, and so forth. Client traffic, if you will. There's also the ability of the MAPI network that also talks to things like Active Directory, that also talks to DNS. It's part of your general corporate networking infrastructure and so forth. Then we have a special kind of network called a replication network. Those are additional network cards that you can put into your DAG members and dedicate them for continuous replication. In other words, the log shipping and the database seeding process. Now, we only require 1 network card inside of each DAG member, but if you want, you can go ahead and add multiple network cards, in which case the extra cards you add beyond the 1 will be your replication networks. Now, there's some important configuration differences between those 2 types of networks. And they're important not just so things operate properly, but they're also important because when the system does its initial enumeration of the network cards, it will look at the configuration information to try to distinguish the NIC you want to be the MAPI network from any other NICs that you want to be the replication network. So for example, the MAPI network will have client for Microsoft Networks enabled. It will have file and printer sharing enabled. If it's in a routed environment, it will have a default gateway. And it will also be registered in DNS and have the ability to look to DNS servers to do name resolution. Now, the replication network is different. We only need that for replication purposes. And since we don't use SMB-based log shipping anymore, it's all TCP-based, you don't need client for Microsoft Networks. You don't need file and printer sharing enabled. Even though it may be in a routed network, it won't have a default gateway, and we'll talk about how you get around that in a minute. But in a Windows cluster, only 1 network interface should have the default gateway, and that's going to be the MAPI network. And then it also won't be registered in DNS. So in other words, any names and IP addresses for your replication networks won't appear in DNS, and that interface itself won't have the ability to do DNS lookups. Now, all DAGs have a requirement to have exactly 1 MAPI network. That means 1 and only 1 NIC that's dedicated to the MAPI network. Yes, you can use teaming, network interface card teaming for your MAPI network. But if you do so, you're doing so in fault tolerance mode, not in any form of load balance mode. Generally, though, we find most customers don't go the route of teaming simply because it's that extra layer of complexity. It's a little bit more expensive. And given the way the system is designed, teaming isn't really needed. We have failover logic in there so that if the 1 network that acts as your MAPI network dies, The network card goes away, you lose network connectivity because of a switch or the network cable. The entire server is designed to do a server failover, and all of the active databases on that server become active on one or more other DAG members. So it's okay to let the MAPI network be unprotected in that fashion because the system is specifically designed to protect you in that way. Now, every DAG can have 0 or more replication networks, which means for the first time ever, a highly available mailbox server only requires 1 network card in it. All previous versions of Exchange, we always required 2 network cards, one that would be used as a backup for the other one, if you will. So now we only require 1. And we actually have done a lot of internal testing. We've shown that if you're using gigabit Ethernet for that 1 network card, that even when you're doing a database reseed operation, that reseed operation does not consume so much bandwidth that it will take bandwidth away from client traffic. Okay, we've shown that you can successfully get away with a single network card. And actually what it might come down to is your underlying network topology. You certainly could have a MAPI network and a replication network that were configured separately as different NICs, but they may be going over the same physical wire from the one server all the way to the other server, so it might not make that much sense to have that extra NIC in there. But if you happen to have redundant physical network paths, then you definitely want to look at using separate traffic, because now you can really isolate your replication traffic from all of your client traffic as well. Now there's other networks that you can have inside DAG members. We'll talk about those in a minute. Typically those are what customers sometimes call backup networks. And then there's the iSCSI networks that might show up if you're using iSCSI storage as well. We'll talk about how to deal with those in a minute. We're really only focusing on the 2 types of DAG networks, the MAPI network and the replication network. DAG networks are automatically added to the system when you add that mailbox server to the DAG. So you've created the DAG object, it's empty, now you've got to put servers in it, you run add DAG server, the server joins the underlying cluster, and the cluster at that point looks at all the network interface cards inside that DAG member. And for each subnet it finds, it will enumerate 1 network up into the Exchange stack. The Exchange stack takes it from there, and it turns each one of those networks into a DAG network. So there's really initially a 1-to-1 mapping between the number of subnets that you have inside the DAG member and the number of initial DAG networks that you're going to get when you add the server to the DAG. Now you can add networks later on, and I'll talk to you about the process of how that goes. But initially, the cluster and the DAG are doing all of that enumeration for you and setting up those DAG networks for you by default. Now remember, I talked about the configuration changes. To determine which one you want to be the MAPI network and which one you want to be the replication network, the cluster service passes all of the information to it. The whole TCP/IP stack goes up into Exchange. And Exchange looks for the presence of a default gateway, and it'll look for the presence of this network is registered in DNS as well. And when it finds those settings, it's going to automatically assume that that's your MAPI network. When it looks at the network card and doesn't find those settings, it will assume you intend that to be a replication network. One other point I got to make, it's not on the slides, but it's definitely worth mentioning, all DAG members must have exactly the same number of NICs in them. So if you decide you want to use a replication network on one DAG member, you have to also use a replication network on all of your DAG members. All DAG members have to have the same number of NICs in them. One other thing worth mentioning is, as well, is if you are using multiple replication networks, which not a lot of customers are, but if you are, there's a least recently used algorithm that the system will automatically use to try to load balance across those multiple replication networks. So least recently used means I've got data to replicate. Which one of my available replication networks was used least recently? Okay, the one I used way back when, and now I've used some others. That's the one it's going to try to go over. That one's not available, it'll try another replication network. If all replication networks are unavailable, it will try the MAPI network, as we'll talk about in a bit. Now, about 6 months ago, we had a support change. We used to require no greater than 250 millisecond round-trip return latency between all DAG members, regardless of where they were physically located. We changed that. We realized that there are some customers who, although that's very high latency, had low enough log shipping traffic such that they could tolerate that high latency, and the solution was still able to keep up. So what we did was we increased our latency support boundary. We actually doubled it. We went from 250 milliseconds to 500 millisecond round-trip return latency. That's a half a second of latency. That's extremely high network latency. If you have that kind of latency, even though you're within our support boundary, there's still other things you might need to do if your log shipping traffic is too excessive. And of course, it's not just log shipping traffic that may be going over that pipe. It might also be Active Directory traffic, AD replication, AD lookups, DNS, other application traffic, other client-related traffic, and so forth. So that might mean even though you've got the high latency, but you're within the support boundary, you might need to go with more databases instead of fewer larger databases, maybe more smaller databases. That way you minimize the amount of log traffic going on a per database basis. If you've got one large database, everyone's hitting it, that's going to mean much more log traffic for that one single database. And of course, there may be other things that you need to do. Depending on your environment, that latency threshold simply might be too high. You might actually have clients also going over that same network connection, talking over the WAN from wherever they're located to a client access server, or maybe they're talking to a local client access server, but that local server is now talking over the WAN to a remote mailbox server. Once the latency gets in the middle of the client connection, generally anything over 250 milliseconds is going to translate into a pretty poor client experience. Okay, so even if you have high latency and you can sustain the log shipping, the client experience might be a driver that causes you to upgrade or do something about your network to increase bandwidth and, more importantly, reduce latency as well. So let's talk about some examples of how the network configurations become DAG networks. So this is a very simple example. I've got a two-member DAG. Each one of my nodes, EX1 and EX2, they have two NICs in them. One that I want to be my MAPI network and one that I want to be my replication network. And so I've configured the ones I want with the MAPI network on the 192.168.0 subnet, and I've also given them a default gateway. The replication network's just on 10.0.0, and it doesn't have a default gateway. In a routed environment, how would I route the replication network across there? Simply put, static routes. That simple. When you don't have a default gateway, you have to hard code static routes into the system. And the way in which we recommend that you do it, there's a couple ways. You can use route add or netsh, but we've actually found route add to be a bit unreliable. We've seen several cases in which you add a persistent route with route add, and later on something happens and that route simply disappears. We have, however, found netsh to be very reliable, and so that is what our documentation tells you to do, and that is the best practice recommendation for doing that. Simply put, you're configuring static routes. Okay, so knowing that I have two network cards in each for a total of 2 subnets in this DAG, how many DAG networks do you think I'm going to get? Just shout it out if you think you know the answer. I've got 2 subnets, so how many DAG networks would you expect to be enumerated by the system? 2, that's right. 2 DAG networks. And in fact, these are the default names we use: DAG Network 01, DAG Network 02, 03, and 04. You can go and rename them. I'll show you what that looks like a little later. But these are the default names that we use. And you can see it found which subnet was going to be for which. And of course, it's got multiple interfaces, one for each server in that subnet. And then it will set some other properties as well. Because it realized DAG Network 01 was the MAPI network, it set the MAPI access enabled property to true. And it also went ahead and set replication enabled to true, but we're going to modify that in a minute. But it also detected that I wanted this to be a replication network, and so it set the MAPI access enabled bit to false. It says that's not a MAPI network. This is going to be a dedicated replication network, and of course, replication enabled will be set to true as well. Okay, that's a very simple representation. Things are going to work for you right out of the box. There's really no other configurations that the administrator would need to do at this point, except unless that they wanted to disable replication on the MAPI network, which we'll talk about why or why not you might want to do that in a little bit. But otherwise, this is good to go out of the box. It detected everything. It set them all up for you. You don't need to do anything. It's all set to replicate over the replication network as needed. Let's look at a slight variant, though. Now I've got the same exact servers, except now EX1 and EX2, they're on different subnets. They're maybe in different data centers. Maybe one's on one floor in the building, the other's on another floor. Maybe one's in one building, the other's in another building. Doesn't matter. They're just on separate subnets. In this case, EX1 has its MAPI on 192.168.0, and EX2's MAPI is on 192.168.1. Similarly, EX1's replication is on 10.0.0, and EX2's replication is on 10.0.1. Now in this case, knowing that I have 4 subnets, when I add these servers to the DAG, how many DAG networks am I going to end up with? Exactly, 4. Now here's where things get complicated. Here's where things require an administrator to come in and make a configuration change to get the system working as you might expect it to. Hey, what's the problem with this? If we look at the mapping network and the replication networks, we can see they only have one interface in them. Now, what's the minimum that you need in order to have a network? 2, that's right. I need 2 endpoints. None of these networks have multiple endpoints in them. So what happens is the system has logic built into it that says, when I'm looking at my replication networks, if I don't have 2 endpoints, I don't have a single cohesive network. So in that case, I need to use a fallback mechanism to figure out how to replicate. That fallback mechanism is simply a DNS lookup to find the other DAG member. Now, which is the only network interface registered in DNS? The MAPI, that's right. And as a result of that, until you do the configuration change I'm about to show you, in this configuration out of the box, the system will only use the MAPI network for replication. And that's, of course, the opposite of your intent, because after all, in this configuration, you put a dedicated replication network card in there. So how do you get it to work? Well, it's actually a very simple process. We call it collapsing your DAG networks. And basically, all it involves is taking interfaces out of a couple of these networks and putting them as interfaces here. Or more specifically, stealing the subnets out of each of these DAG networks and adding them to the 2 DAG networks I want to survive. So I'm happy with DAG network 01 and DAG network 02 being the actual networks I use. And so what that means is I need to take the subnet from 3, add it to 1, and take the subnet from 4 and add it to 2. Then once I do that, 3 and 4 become empty networks. At that point, I simply remove them. Now to do all this, there's actually 4 commandlets that you would run. And because they're word wrapped, I've color coded them for readability. So white, yellow would be the commands. The first one, as you can see, we're using set DAG network, and we're giving it the identity of the network we want to keep, in this case DAG network 01. We're adding the subnets we want, and it's important that you use both subnets. Whatever value you specify here would overwrite what's already there. So I can't just add subnet 1, because that'll replace it with only subnet 1. I have to add subnet 1 and 2 and say, these are all the subnets I want to be part of this DAG network. Then I'm also going to add and set replication enabled to false, because that's my MAPI network, and I don't want that least recently used algorithm to kick in and use the MAPI network for replication. I only want the system to use the MAPI network for replication unless and until the actual replication network is dead or otherwise unavailable. Then, even with that flag turned off, even with replication enabled set to false, the system's still going to use the MAPI network for replication. It's a fail-safe mechanism we have in there that says, don't use it for normal replication, but if actual replication networks disappear, use the MAPI network to keep high availability up and running. Then I'm going to do a similar thing. I'm going to take the same commandlet, only this time I'm focusing on DAG network 02, and I'm taking both subnets in there. And as I said, at this point, DAG network 03 and 04 have no subnets and have no interfaces. They're simply empty DAG networks at this point. So what I do at that point is I use remove DAG network and get rid of both of those networks. And when I do that, now the configuration looks like this. I'm down to 2 DAG networks. They each have 2 subnets associated with them. That gives them both interfaces. My MAPI access is turned off for this one. Replication set to true. Actually, MAPI access, sorry, that's a typo of mine. This should be set to true. Replication enabled should be set to false. So these are reversed here. Sorry about that. But on DAG network 02, MAPI access should be disabled. We want that set to false because it's a replication network. And replication set to true, of course, is what we'd expect for the replication network. So unless and until you do this, the system's only going to replicate over the MAPI network. And that, obviously, you don't want that to happen. Now, I mentioned this automatic detection enumeration. We just went through all of that. That only occurs when you add the mailbox server to the DAG. We interrogate all the interface cards, and for each subnet that you have in there, that will bubble up and enumerate to become one DAG network. But let's say you've started out, you've just got one MAPI network card in there, and you realize, now we have a separate physical network. I want to throw a replication network card in there. How do I do that? Well, you take down the server, you put the card in there, you bring the server back up. Windows will detect it right away, but the cluster and the DAG will not. You'll have to manually discover the networks that you added, but that's an easy thing to do. You just run set DAG with the discover networks parameter, and it will go and reinterrogate all of the DAG members, find the new card that you've added, and turn it into a corresponding DAG network, assuming, of course, the new card that you've added is on a separate subnet. If it's on the same subnet as one already exists, Cluster doesn't allow that as a separate network, so the DAG won't see that as a separate DAG network. So each one has to be on a separate subnet. Once you do that, the DAG will recognize it once you've forced this discovery. Now, the DAG network configuration is all held in the cluster database, inside the registry of the cluster database. What that means from your perspective is that in order to write to that database, the solution must have quorum. If your solution does not have quorum, you won't be able to make any networking changes to it because we need quorum in order to write to the database. So that's a key element. You won't be able to do things like change the replication port, change the encryption settings, change the compression settings, and so forth, simply because we have no mechanism by which to persist that information if we can't write to the cluster database. DAGs now do include built-in encryption and compression as well. I know I've heard through a few sessions that some of you are using WAN optimizers that are already providing you with some WAN compression benefits. Some of you may also be using IPsec policies with your legacy clustered mailbox servers in order to get encryption for that solution. You don't need to use either of those anymore with the DAG. The DAG includes built-in compression and built-in encryption. You configure it at the DAG level, at the DAG object level itself. In other words, your choices are encrypt is always on, it's always off, or inner subnet only encrypt or only compress when we go across subnets. And that, in fact, is the default, inner subnet only. And you can turn them on and off at your convenience. Obviously, if you are already using WAN compression technology, don't turn on our compression. It's not going to do anything for you. Something's already compressing it, and you can only compress something once. But if you're not using it, we do recommend that customers turn it on. We have it running inside of MSIT, and we've got a pretty healthy mix of both rich text and HTML-based email, maybe a little bit more on the HTML side. And so for us, we see a pretty good savings over the wire. We see about 30% savings on the wire with compression enabled. Of course, your actual ratio will depend on what type of content you have. If you're heavily using RTF, that's not very compressible, so your ratio is going to be lower. If you're heavily using HTML or other compressible formats, then you may even see a higher ratio as well. But either way, those are both built in. The compression, we use a proprietary implementation of the LZ77 compression algorithm. So it's one that's used all over the place. gzip is a variant of that. In fact, we use that inside OA to do some compression in there as well. And the encryption, we're simply using the operating system's Kerberos encrypt and decrypt APIs to handle that. So that's how we can include it in the box as well. So lots of good stuff in there that we didn't have before that you can now leverage and secure your environment and optimize it while saving money as well. Now, when you're using a single NIC, when you've got just one network card inside each DAG member, that one NIC is acting as both your mapping network and your replication network. And in that case, enable replication is going to be set to true because it's the only single network that you had, and there's no reason to uncheck that box. If you've got multiple NICs, then one NIC is going to be your mapping network, in which case enable replication will be set to false. And the other NICs, the multiple NICs that you have in there, they would be your replication networks, and they will have enable replication set to true so that that algorithm can choose between them when it's got a seed or a log shipping operation to do. If your replication networks become unavailable, even if you've disabled replication on the mapping network, we will revert to using that. Now, some people mistakenly believe that when you repair your replication network, we'll automatically fail back to using that. We won't. There's only two ways we will go back. Once we start using the mapping network in that scenario, there's only two ways we'll go back to using your replication network. One is if you disable the mapping network. Don't do that. If you disable the mapping network, you're going to cause a server failover. You don't want to do that. Certainly, you could do a server switchover and then disable and re-enable, but don't do that easier. The other way is much simpler, and that's simply to suspend the mailbox database copy and then resume it. A quick suspend and resume is basically just suspending replication and resuming it right away. And when you do that, it'll pick up the replication network and start using that again. And because you're only suspending and resuming replication, it's just a brief outage for log shipping, like a 3-second outage, if you will. It's not going to impact clients or anyone connected to it. None of the end users will know this is happening, but it's the quickest and pretty much the best way to switch back automatically to the replication network. So this is what it looks like. See, you've got the ability, if I'm looking in the Exchange Management Console, I can rename a network. So if you don't like DAG Network 01 or DAG Network 02, typically I recommend renaming them to like MAPI Network or Replication Network. It's very convenient for other administrators who might come in and not be familiar with the initial configuration. Give it a good name. You also have the ability to give it a description as well. Feel free to give it as much as you want in there. And then here, if you wanted to manually, the commands I showed for collapsing networks were how you would do it in the shell. You can collapse inside the GUI as well by adding subnets, removing subnets, and so forth. And then here is that enable replication checkbox that says enable replication to true or false. Obviously, if it's checked, it's true. If it's unchecked, it's false. So typically on the MAPI network, this is going to be unchecked unless you've only got one network. And typically on all your replication networks, that has to be checked or it won't be used for replication. Now, there are some other configuration changes that you have to do as well. Now, how many of you have heard of the concept of a cluster heartbeat network? OK, wow, that's a lot of you. OK, so I don't want to embarrass anybody here, but the reality is, and this may come as a shock to those of you who just raised your hand, there is no such thing. There's no such thing as a cluster heartbeat network. Just get that concept out of your head. In Windows failover clustering, all networks are heartbeated by design. There's no way really to control that. The system is designed to heartbeat all networks. One of the reasons it's designed to do that is so it's able to distinguish between a server failure and a network failure. There's no such thing as a dedicated or private heartbeat network in a cluster. So just throw that thought away. It's never existed, and it still doesn't. It's this mythical unicorn that you will never, ever see out in the wild. It simply doesn't exist. But some people think of it because we used to use the terms public and private network. The real difference between those two networks was not from a heartbeat standpoint, but from a client access standpoint. Whether or not a client could access that network. That's a public network. If a client can access it, it's a private network. But all networks are heartbeated. And that becomes a challenge in a DAG that has multiple network cards in it, particularly if you have a large DAG that's extended across multiple sites. We know that the DAG can go up to 16 members. And if you've got 2 NICs in each of your DAG members, that's 32 interfaces. 32 interfaces over which heartbeat traffic will occur. Okay? Now, we don't want heartbeat traffic to cross networks. We don't want, for example, heartbeat traffic to go from the MAPI network on one server to the replication network on another server, or from replication network number 1 on one server to replication number 2 on another server. You want to do what we call blocking that heartbeat crosstalk. If you don't block the heartbeat crosstalk, that's a lot more traffic going on that you don't want and you don't need. You want to block the crosstalk. This is a very simple representation. Each one of these green blocks is a server. And each one has 2 NICs in it. This one has 1 NIC that's on subnet 1 and 1 NIC on subnet 2. So does this. This one has 1 NIC on subnet 3. So does this. And they each also have 1 NIC on subnet 4 as well. So let's just say that subnet 1 and subnet 3 are our MAPI network, and subnet 1 or subnet 2 and 4 are the replication network. So we want to allow traffic from subnet 1 over to subnet 3. That's our MAPI network. We want that heartbeat traffic to go. We want to know if that other MAPI network or the server hosting that other MAPI endpoint has died. We want that heartbeat traffic to go there. But what we don't want the MAPI network here on subnet 1 to be able to access and heartbeat the replication network over here on subnet 4 on this other server. We don't want that because if we can get heartbeats across, then now the system can no longer distinguish between a server failure and a network card failure. Okay? And you want the system to be able to distinguish that. because it's only a failure of the mapping network that would cause a server failure. A failure of the replication network won't. And if you're allowing those heartbeats to get across, if it finds a pathway exists, it may not trigger that server failover you expect, even though this subnet has no access to the mapping clients that are trying to get to their mailboxes. So it's very important that you do this. Two different ways you can do this. One is just like you're handing out static routes with NetSH, you can use NetSH to also block that as well. But a more common way of doing it is to use router ACLs and simply ACL the traffic so that your router is blocking traffic going from a MAPI interface on one server to a replication interface on another server. That's probably the easiest way to do it. Although if you're in a large environment, you may have some work that you may need to go through with your network guys to help them understand why you're doing this and how and which segments actually need the blocking and which ones don't. Okay, so it's very, very important that you do this. Otherwise, you're just going to be awash in heartbeat traffic, and that's going to be consuming bandwidth and adding latency to the solution that you don't want. And as I said, more importantly, it will strongly diminish the system's ability to distinguish between a network failure and a server failure. Let's talk about some other types of networks that we use. Some folks like to throw in a dedicated backup network card in there. You can do that, although it's nothing that we require from a DAG or from an Exchange perspective. You would do so if you had a business requirement for that need. But it's more common for customers to be using iSCSI storage with their DAGs. In fact, that's becoming more and more common, particularly as they virtualize, given the enhancements in the guest networking stack that now really make iSCSI a very doable solution, even in a virtualized environment. So with, for instance, Windows 2008 R2 and the network stacks that support things like jumbo frames, now iSCSIs are getting to be a more and more common way of doing that. But iSCSI, just like maybe your dedicated backup network, that should be isolated traffic. Those networks should be isolated to that specific purpose. You should never share an iSCSI network with anything other than the initiator and the target and, of course, the storage endpoint. Otherwise, all other traffic should be completely isolated and segregated. Now, one of the cool things about Exchange 2010, and in particular the DAG, is this concept that we call incremental deployment. And that's just our fancy way of saying, unlike previous versions where you had to install the cluster first and then do Exchange to get high availability, now there is no clustered version of Exchange. You just throw Exchange on the box and you configure it for high availability after the fact. That's what we call incremental deployment. So that means you might already have all your storage set up, all your mailbox databases set up, maybe they have data in them and so forth. So when you add those DAG members to the DAG, any iSCSI network cards are also going to be detected by the system and enumerated, and they're going to turn into DAG networks. Now, you don't want your iSCSI networks to be DAG networks because those iSCSI networks should not be used for MAPI access, and they certainly shouldn't be used for replication purposes. So there's two things that you need to do in order to get both the DAG and its underlying cluster to ignore those networks. The first thing you want to use is this set DAG group network commandlet, the same one we used for collapsing DAGs. And you give it the identity of the DAG network name. You turn replication off, but then you also set ignore network to true. This is the administrator's way of telling the DAG that I have these network cards in there and I know you see them, but do not use them. Don't use them for any purpose. Ignore them. You don't use them. They don't exist from your perspective. That takes care of the DAG. The second thing you need to do is run this cluster command, cluster network, with the cluster network name, and then set the property, the role property, to 0. That's basically the equivalent of going into Windows Failover Clustering Management Tool and checking the box that says, do not let clients use this network. In other words, it's also a way of telling the cluster, ignore this network. Do not cluster manage this network. Once you do both those things, your iSCSI networks, or if it happens to be a backup network, you're covered. You've isolated them from the DAG, you've isolated them from the cluster, and even if you go back and you do set DAG and you force discovery of new networks, any network set to ignore will be ignored in that discovery process and won't keep popping up every time you do that. Okay, so keep that in mind. This is especially important. You don't want the DAG or the cluster to use these very special and dedicated networks. Now, in terms of DAGs that span multiple subnets. You saw in the collapse example that each one of my DAG members had an IP address on different subnets for the MAPI interface. And that is in fact a requirement. For every subnet in which you're going to extend your MAPI network, you will need an IP address on that subnet for that interface. Okay, that shouldn't be a surprise to anybody. That's the same sort of requirement as if you were stretching almost any clustered solution across multiple subnets. The key here, though, is you don't see the word VLAN anymore. You don't see the word stretched LAN anymore. You don't need any of that stuff. Okay, we will operate in a multi-subnet environment just fine. And in fact, we've been operating with clustered mailbox servers in a multi-subnet environment since Windows 2008 and Exchange 2007. So that should not be, hopefully, anything new to anybody else. Now, one other tip that we have here is you do need to deploy those static routes for your replication gateways. And actually, if you go ahead and use DHCP to assign addresses to the replication interfaces, you can send the IP stack, the full IP stack down with that IP address lease. Okay, that means, in other words, you can send the static routes down that way as well. You don't necessarily have to go to each box and do NetSH. Now, you may still want to do NetSH on each box, because if you do go the route of using DHCP, which will be new for most of you, I bet if I'll just ask this question, how many of you are using DHCP for highly available resources today? Yeah, exactly. No one is. And the reason for that is because as a high availability architect, you already know that the fewer external dependencies I have, the better it is for the solution. But if you're warm and fuzzy with DHCP, we do have highly available solutions for that. If you know it's highly available and it's not going to go down, you can do reservations for the address that you want, and then also get the benefit of using DHCP to send down the routing stack as well. The other thing we want you to do is in DNS, in a site resilience configuration, you're going to need to lower the time to live on your DNS records. So whatever namespaces that you're using for OWA, ActiveSync, EWS, Outlook Anywhere, SMTP, lower the time to live on those to something that corresponds to whatever your service level agreements is for restoring service in the event of an outage. So for instance, if you have like a 45-minute to a 1-hour SLA in order to get a recovery site back up and running, you'd probably want to set your TTL pretty low, down to about 5 minutes or so. So that is a best practice. Okay, so that's DAG networks, and that isn't even the most difficult thing we're going to talk about. Now we're starting to get deeper and deeper into the product, starting with this discussion of Active Manager. Okay, so Active Manager, as I discussed in the concept session, how many of you were in the concept session? Okay, almost everybody. So if you didn't see the HA concepts, Active Manager is now the brain of the high availability platform. Remember, in this new model, there's no clustered mailbox server. The cluster has no idea that Exchange is even there. Okay, what that means from an Exchange perspective is if we have a failure affecting a database, affecting the network, affecting the server, the cluster can't do anything for us anymore. It has no resources to move to another system. We no longer use the cluster resource model. There are no Exchange resources in the cluster anymore. So what that means is we had to have some other mechanism, some other thing that could monitor for us, and when something went wrong, take corrective action. That is, in fact, what Active Manager is. It is our high availability resource manager, among other things, as you'll see in a moment. Now, there's 3 Active Manager roles. And by the way, don't go looking for an Active Manager service. There is none. Active Manager is a code component that runs inside the Microsoft Exchange replication service. And that's a required service on all mailbox servers, whether they're a member of a DAG or not. And it's required because, as you'll see in a moment, Active Manager is now the gatekeeper for mounting databases. Yes, the information stored still does the actual mount and the attach to the database, but it will only mount a database if Active Manager tells it to do so. So you're going to want to know Active Manager very well. Now, there's 3 Active Manager roles. There's a standalone Active Manager that's on every mailbox server before it's a member of a DAG. That's not so interesting from our discussion purposes today, so we're not going to talk about that. But be aware that it exists and it's there and doing some of its functions on standalone mailbox servers as well. But then in the DAG, there's 2 other roles. The primary Active Manager, what we call PAM, and the standby Active Manager, what we call SAM. Okay, so you're going to get to know PAM and SAM quite well. And you'll see actually the PAM can become the SAM and the SAM can become the PAM, as I'll describe further. And as they transition, maybe you add the server to a DAG, so it's now transitioning from a standalone to either PAM or SAM. Or you've added another server to the DAG and there's already a PAM in there, so it's becoming the SAM and so forth. All of that transition, all of the role information is actually evented inside the Windows event log, but it's done so in a special area called the Crimson Channel, which is new in Windows 2008. It's not like the application or system or security log. This is a special area that's under Microsoft Exchange High Availability / operational. And in fact, you'll find this under Windows and Services in Event Viewer. So if you haven't dug down into there, I strongly suggest that you do that because there's a lot of great eventing that we do in there. So what does that transition look like? Here's a server, E14EX1. Active Manager's been running in a standalone. It's not a DAG member for, in this case, 3 days. So I've had the standalone server up and running. It's doing its thing. It's been a servicing mailbox server for a while. And now I want to make it highly available, so I add it to the DAG. Okay, so you can see it detects a configuration change. The previous role was standalone. And the current role, in this case, because it's the first server I'm adding to the DAG, is going to be the PAM. Okay, we always need the PAM, and it's always going to be the first server will inherit the PAM role automatically because it's the first one. And you can see all of the rich eventing that we do. We track how long it's running, that the change was detected, that we actually made the change, and then how long it's been running in the PAM role, which is just less than a second in this particular case. So any transitional states related to Active Manager all get logged in here and giving you very rich visibility as to what's going on. Now, here's Active Manager roles changing from standalone to SAM. I've taken server 2 now and I've added that to the DAG. Okay, because there's already a PAM, this isn't going to be the PAM. Server 2 now inherits the SAM role, and you can see that transition logged as well. Now, here's a case where I went ahead and moved the default cluster group from EX1 to EX2. We have a rule with the PAM. It's always going to be held by whatever DAG member owns that default cluster group. And that was actually a very natural thing for us to do because at any given time, only one DAG member will own that group. And as that group moves around, so does the PAM role with it. So I move the group, and you can see the role changing here from SAM to PAM. And back from PAM to SAM, going the opposite direction. Here's EX1. It used to be the PAM. Now it's the SAM because the PAM role was moved off of it. So what does Active Manager do besides being given some cool names like PAM and SAM? It almost sounds like a Dr. Seuss book, but it's a bit more complicated than that. There are no green eggs in ham, for example. OK, nobody got that. All right, so what does Active Manager do? So as I said, it mounts and dismounts databases. Okay, so it's providing the administrative interface. When you go into the console and you say dismount database or mount database, it's Active Manager that decides whether or not to tell the information store to carry out that action. Okay, Active Manager is the gatekeeper now. The store just doesn't do a mount. The store cannot do a mount on its own. It's programmatically prevented from mounting or dismounting any databases unless Active Manager tells it to do so. So Active Manager controls everything. And it's important then that that service is always running, not just from the log shipping and replication standpoint, but even from a simple mount and dismount perspective. It also provides database availability information. It's now the definitive source of where a database is active and mounted. Historically, with previous versions, we stored this information in Active Directory. But in this new model, where we have the ability to have a database failover take place within less than 30 seconds, we can't store that information in AD anymore. We'd be totally bound by AD replication latency, and we would never be able to get the failover information stored around that quickly. So instead, what we do is Active Manager tracks all that information by writing it into the cluster database. And anytime you write something into a cluster database, it's instantly replicated to all of the other cluster members, in this case, all of the other DAG members. So all of the Active Manager components inside the DAG know at any given time where a database is, where it's mounted, where it's active and where it's mounted. As I said, it also provides the interface for all of the admin tasks. It's also all RPC based, so you're going to want to be aware as to where the PAM role is relative to the workstation that's executing the task. Because your workstation might be talking to a DAG member that holds the PAM role in a foreign data center, in a remote data center, which means now you've got RPC traffic going over the WAN. That could slow down your task substantially. So always be aware of where the PAM is as well. It also, of course, monitors for failures. Remember, the cluster can't do that for us anymore, so Active Manager monitors for failures. Sometimes, though, the monitoring is done as a result of other components reporting a failure into that Crimson Channel event log stream, and Active Manager monitoring that stream and taking the corrective action. So, classic example, the disk hosting your database and your log files goes away. That's going to translate into an ESE error. ESE is going to complain that I can't write to this database, I can't read from the database, I can't write to the log stream, I can't read from the log stream. And ESE is going to complain in the form of Crimson Channel event logs. Active Manager sees those Crimson Channel event logs and takes corrective action as a result of it. Okay, that's just one example. And it also, as I said, maintains all of the database and server state information. So all the health and status about the copies, not just where a copy is mounted and active, but what's its copy queue length, what's its replay queue length, what's the health status of the database, what's the health status of the content index as well, which is also tied into the high availability platform. Okay, so you've got the search catalog to deal with as well. So let's talk about some of these operations, starting with the auto mount. That's just what Active Manager does when you start up a server during normal operations. It goes through this auto mount process to determine whether or not the active databases or the databases that are supposed to be active on that server should be mounted on startup. Okay? It's very similar to the process that the store used to go through to determine whether or not it should mount a database on startup. But there's some extra things in there because it's in a replicated environment and it's in a DAG being managed by Active Manager. So, for instance, one of the first things it does is Active Manager needs to see, well, is this particular database, is this a standalone database or is it replicated in a DAG? How do we figure that out? We look at this property. This property tells us, is there a master server or availability group for this database? Is this database part of a server that's a member of a DAG? Okay, it checks that. And then it looks at this flag, that checkbox that an administrator can check that says, do not mount this database on startup. It will look at that flag. If that flag is checked, the admin said don't mount it, Active Manager stops at that point, and it will not mount that database. If that's unchecked, the admin says, yeah, it's OK, go ahead and mount this on startup. Then Active Manager sees that value set to false. It's not set to do not mount. And so we'll go ahead and proceed with the rest of its logic. The next step is it's got to check in that cluster database, in that persistent registry information, and just verify that the database that it's being asked to mount actually exists. It's being tracked by this Active Manager instance. Okay, perhaps the database that you've chosen is not one of the databases that are in there. Maybe there's something wrong with directory replication and a new database hasn't appeared yet, or an old database hasn't disappeared yet. Either way, we're going to check for that. It's also going to check and verify if it's mounted on another DAG member. Obviously, if you're asking us to mount a database that's already mounted somewhere else, there's no work for us to do. The task will fail at that point, and it will say, I can't mount it. It's already mounted on this server. But of course, let's just say it's the regular operation. It's starting up and the database isn't mounted, so it's not going to be mounted. It'll proceed. The next thing it checks is to see if an administrator dismounted this database manually prior to it shutting down or prior to it restarting. Okay, because we want to honor the administrator's intent as well. The administrator may not have checked that box that says do not mount, but there's another way that they can tell us. If they just manually dismount the database, we'll store that in the cluster database. And when we see that flag, that will also tell Active Manager, don't mount this database. The administrator had it dismounted when we were last running, which means now that we're running again, don't mount the database. Let's keep it back in that same state. The administrator will manually mount that database when they're ready to do so. So we honor the admin's intention. Then we also have to check the state information as well. We have to make sure that we've got a database that's mountable, that it doesn't have some sort of copy status that tells us it's not a viable database. It's not something that we can use. Once we determine it's mountable, we can go ahead and issue the mount request to the information store on that server. If it turns out the local server, the store that we're talking to is local, but it doesn't host the database, then we will issue that mount request remotely using RPC, with the replication service reaching out via RPC to the remote store service and requesting the mount information, the mount operation that way. Then, if the auto mount operation succeeds, Active Manager immediately logs that into the cluster database, and then all of the other DAG members get instant notification of that because the cluster database changes are instantly replicated between all of them. So it's a very, very fast operation. Let's talk about some admin tasks. Obviously, that was auto mount. Auto mount meaning the system's doing the mount operation automatically. Okay? There's administrative tasks. An administrator can also go and mount a database. Maybe the system couldn't mount it because some of those flags were set and that told the system not to mount it. Or maybe an admin's dismounted the database and now they just need to mount it for whatever reason. Okay? So when the administrator does those operations, Active Manager is still doing its thing. In fact, the mount operation is pretty much the last operation in the move. If an administrator says, activate this database copy over here, they're running move active mailbox database. And that move operation, the first thing it does is dismount the existing active, and the last thing it does is mount the new active. Okay, so that's another way that an admin can trigger the mount and dismount simply by doing a move. It's not just a mount operation. So what happens when you initiate a mount operation through either mechanism? Well, we're going to be doing RPC communication into the DAG. If we happen to contact a SAM, the SAM's not going to be able to do anything. The SAM will refer us to the PAM, and the PAM will go ahead and initiate the tasks based on some of the checks that you saw. It's only the PAM that can actually take action inside of a DAG, with one very small exception, which we'll talk about in a minute. But really just think about it as really it's only the PAM that can take these types of actions. Then, of course, it's going through the same checks. I'm not going to run you through all of them, but I wanted to include them for completeness. It's got to make sure it's hosted in the DAG for the Active Manager that we're talking to. The DAG acts as a boundary not just for replication, but it's also a boundary for Active Manager. So each DAG that you have in your environment has its own Active Manager that is separate from any other DAG, and that Active Manager is only responsible for its own DAG. It doesn't manage outside the DAG. Then again, we got to check and see if the database is already mounted. Obviously, if it is, there's nothing to do. If it's not, we can proceed. PAM will then do a callback there. It's actually doing a pre-check callback just to make sure that the database is ready to be mounted. Again, it's looking at a lot of status information to figure out whether or not this database is mountable on the server that's being requested. Then, once it agrees that it is, the PAM itself is reaching out via RPC to the information store. Maybe it's the local store, maybe it's a remote store, it could be either, both are valid. But either way, it's RPC traffic over there, and it will ask the store to do the mount. Once the mount succeeds, assuming it does, then we'll update that persistent information inside the cluster database and replicate it around again. Okay, pretty straightforward stuff, but it's interesting to see what's going on. When you dismount, it's very similar to the mount operation, except here, once again, we're going to the PAM, checking that it's in a DAG, verifying that it's in a mounted state. Obviously, if it's already dismounted, we can't dismount it twice. So assuming it's a mounted database, we would go ahead and pass that check, and then dismount it, update the information via the store again. The store is still doing the dismount, and then Active Manager will update the rest of the DAG members with that information. Pretty straightforward stuff. Auto dismount. This occurs when a DAG loses quorum. So auto mount occurs when the DAG starts up. If your DAG member loses quorum, that's when auto dismount starts and kicks in. And in fact, auto dismount is the only case in which the SAM can take a form of corrective action. Okay? Otherwise, all other tasks that you do have to be performed by the PAM. There's one case that allows the SAM to take its own action, and that, of course, is when the DAG member has lost quorum. When that happens, the SAM terminates the information store. And in doing so, that dismounts all the databases. That is the only action that we allow the SAM to do on its own. Otherwise, SAM its real purpose in life is to sit there and respond to queries from client access and from hub as to where a user's mailbox is located. Okay, that's really the only intended purpose of the SAM. The SAM can do monitoring of its local store and local databases, but it cannot act on failure scenarios. Even when the local store or local databases die, SAM has to ask the PAM to take corrective action. But of course, in a lost quorum solution, SAM generally can't communicate with the PAM. So there's no way it could ask the PAM for help. So in this case, we allow the SAM to issue a termination of the store, and in doing so, dismount all the databases and basically take that lost quorum server out of service. The dismount operations should try to update the cluster database, but again, they're probably not going to based on the fact that this is now an isolated server that's lost quorum. And so because it doesn't have quorum, it cannot make any changes to its cluster database. It has to have quorum in order to do that. And the move operation, that's the one that you're all going to do mostly. You, of course, will be doing mounts and dismounts, but most of the manual operations you're going to be doing are move operations. A server switchover, a database switchover, those kinds of things. And the move operation, it's initiated by an administrator, but it's Active Manager that's the gatekeeper here again. Active Manager says, I've got to go ahead and begin with a dismount operation. Okay, once the move happens, I need to dismount the current active database and start the process of activating the passive database that either the admin or the system wants to try and mount. And in fact, that process is called best copy selection. How many of you have heard of this process before? Okay. Now we're going to go deep into that process because it's really the linchpin of how Active Manager provides that corrective action. Yes, it can deal with a server failover, but even when a server fails, you're really talking about just activating databases from that server on one or more other servers. And that process is called best copy selection. It's the core function, aside from monitoring, that Active Manager does. Okay, so best copy selection is simply the process that Active Manager does to determine the best, and yes, I'm saying best in air quotes, I'll explain why in a minute, to use the best copy to select to activate either in response to an admin-driven switchover or to some failure event that drove a server failover or a database failover. Okay? So it goes through this BCS, best copy selection process. Now I say best copy because it uses a set of criteria to determine which database to activate. And because of the varying nature of failures and the differences, the dynamic nature of passive copies and the differences in the criteria, the database copy that actually has perhaps the best overall copy status may not necessarily be the database that's activated as part of BCS. And we'll see why that is in a minute. But it's important that you understand we did change some of the logic. So the first part of BCS in the RTM version of Exchange 2010 is a little different from the first part of BCS in SP1. And I've got some animation that'll walk you through both of them, but there are some differences in the beginning process, in the way that we sort the list of potential copies. So in RTM, what we do is we look at the list of potential passive copies to activate, and we sort them by how up-to-date they are. In other words, by the copy queue length, the number of log files that haven't been copied from the passive, from the active rather, over to this passive. And then from that sorted list, we'll go ahead and check the list, the sorted list. We'll look and see which ones on the sorted list match the set of criteria I'm about to show you. Now, if it turns out that multiple passive copies have the same copy queue length, maybe you've got two copies, both of which have a copy queue length of 0. They were able to keep up. There's another property that we use to act as a tiebreaker. And that property is called activation preference. Talked about it in the concept session, so if you weren't there, definitely you're going to want to see that session after the show on the online version. But basically, activation preference will act as a tiebreaker. It's just a whole number, 1, 2, 3, 4, and so forth. And the lower the number, the higher in the list that database copy would take place. So if we have two copies with the same copy queue length, but this one has an activation preference of 3, and this one has an activation preference of 4, the one that 3 is now higher in the list, and it will be potentially tried first, as you'll see in a moment. Then, after we have our sorted list, one of the next steps that we'll do is the passive copy will try to reach out back to the original active copy and try to copy over any missing log files. So if the copy queue is greater than 0, there's some log files that are missing. And whatever that number is, those log files need to be copied over as part of the ACL process, attempt copy last logs. Now, ACL may succeed, it might not succeed. For our purposes, it doesn't matter if it succeeds because there's a second thing that we'll look at in a minute. But this is the first part that's pretty similar between RTM and SP1 with one change. We haven't fully gone through BCS yet, you've only seen the first couple steps. But the difference that we have in SP1 is in that first step. In SP1, we made a change where if the administrator decides to set the auto database mount dial setting on all of the servers that have a copy of that mailbox database to a setting of lossless, In other words, the administrator has said they will tolerate 0 logs lost and still allow that database to be mountable. In that case, we won't sort the list initially by copy queue length. We will instead only sort that list by activation preference. Okay, so in other words, when the administrator said they won't tolerate data loss, then we're giving more meaning to their activation preference setting. Then we're saying, well, you've already said you won't tolerate data loss, so we don't need to sort by copy queue length. We'll hope that ACL will get all the log files for you, but we can't use that as a sorting criteria anymore because ideally, you're going for a copy queue length of 0. So instead, we use activation preference as a sorting criteria, again, with the lower number being higher in the list. That is the only difference in BCS between RTM and SP1. Otherwise, we'll sort the list, ACL will do its thing, and we'll continue from there in a moment. So in both RTM and SP1, after ACL is done, there's a question that Active Manager has to answer. So ACL is going to report success or failure, and whether that succeeds or fails doesn't stop the process. So now Active Manager asks the simple question, is the database mountable? And the answer to that question is really, is the copy queue length, is the number of missing log files that we weren't able to copy over, is that within the admin's auto database mount dial setting? That's the simple question. If the answer is yes, Active Manager will ask the information store to mount that database. If the answer is no, we're outside the dial range, then Active Manager will try the next available copy in that sorted list, assuming there is one. If there isn't one, it's game over at that point and an admin has to intervene. But if there is another one in the list, Active Manager will try that next. Okay, so here's the criteria that it goes through. And you can see the actual criteria. We start at 1 and move our way down to 10. And you can see the quality of the criteria sort of degrading as time goes on. So for instance, we look for the best of all worlds initially, copy queue length less than 10, replay queue length less than 50, and a healthy content index status. If we can't find a database in that sorted list that meets that first criteria, we'll see if any of them meet the second criteria, which is pretty much the same, except we'll accept a content index that's still indexing. It's crawling. It's not up to date, but the database is still good, so we'll go for that. If we can't find something that meets the second criteria, we'll see if any meet the third, the fourth, the fifth, the sixth. Eventually, we get down to see if any meet the 10th criteria, which is, do we have any database that's in a mountable state? Okay, and if we can't find a database in our sorted list that meets any of those criteria, the system doesn't take corrective action and the admin has to fix it. But typically, as you get down to here, you have to either have a system that's very small, so you've got a very limited number of copies, or if you have a very large system, it's got to be in a very, very bad state for us to be down here looking at this criteria. Generally, most of the criteria that's going to hit are the first 4. But again, that's not a guarantee. The actual database copy it will pick as the best copy is really dependent largely on the nature of the failure, the auto database mount and dial setting, and the number of copies that you have in their health and status. So let's see some basic examples of how it works. Much easier to show you with a picture than just to talk about it. And these are very simple scenarios. We've got one DAG. It's got 4 servers in it. The active copies on server 1. We've got passive copies on server 3. And you can see lots of information about those 3 passive copies, the activation preference value, the current copy queue length, the replay queue length, the state of content index, and the database states as well. A lot of rich information for the system to look at here and choose. So we have a failure affecting the active database. Active Manager needs to do its thing now. It needs to do the activation. So again, because this is RTM, we're sorting the list of available copies based on copy queue length. So server 3 has the lowest copy queue length. It's first in the list. Server 2 has the next highest, so it's next in the list. And the largest copy queue length is server 4, so it's last in the list. Now, none of these have the same copy queue length, but if they did, this is when we would use activation preference as a tiebreaker. We don't need to do that here because they all have different copy queue lengths. And then only 2 of the 3 servers in our sorted list meet that first set of criteria that's on the table. Only 2 out of these 3 databases have a copy queue length less than 10, a replay queue length less than 50, and a content index that is healthy. Okay, the other one doesn't meet that criteria. But because we already have at least one database that meets that criteria, we can go ahead and try that first. Okay, it has the lowest copy queue length. It meets the first criteria. This, from the Active Manager perspective, is the best copy to activate. Now, It could be, though, that the nature of the failure could be different copy queue lengths. And it could be that server 1, the reason it failed is because somebody accidentally rebooted it. And so during the activation process, when Active Manager invoked that attempt copy last logs to go back to that original server, because it was still in the process of booting, you couldn't get any logs over. And as a result, the copy queue length might actually ended up being larger than the auto database mount dial setting. And in that case, server 2 would have been tried next. And it could very well be the case that by the time Active Manager goes to try to activate server 2, that the original active servers finish rebooting, and it's up and responding again, and now ACL can get all the missing log files over. And as a result of that, instead of having a lossy failover for server 3, you now potentially have the opportunity to have a lossless failure when activating the copy on server 2. Okay? So again, it's due to the nature of the failure and a lot of things that are moving around. Now, SP1, I said it's a little bit different in the beginning with SP1. Remember, in RTM, we're sorting by copy queue length. But in this scenario, everything is the same, except on all of our servers, we've set the auto database mount dial setting to lossless. The default's good availability, which is 6 logs lost. But this administrator's decided to set it to lossless, 0 logs lost. And so when they set it to lossless, we had the same failure scenario, and all of this is still the same. But now we're sorting by activation preference instead of copy queue length. Okay? Because the administrator said copy queue length doesn't matter in this case because I expect any copy to be automatically activated in a lossless state. If any logs cannot be copied over, that's going to be a lossy failover, and I don't want the system to mount this database. So that's a key difference here. But we're sorting by activation preference. Again, server 2 has the lowest activation preference value here, so it is tried first. Again, if the system can't activate that one, it will try the next one in the list, and so forth, until it's exhausted all potential copies in the list. Pretty simple stuff. Now, we talked about ACL. The ACL process will always be from whatever passive copy it's trying to activate, it will always go back to that original copy. If the original one's not there, ACL won't be able to get any data, and as a result, it will just fail, and we'll move on to the next process, answering that question, is the database mountable, by looking at the setting of the copy queue length versus the auto database mount dial. But assuming ACL is successful, you could actually have the database copy mount with 0 data loss. And in fact, every database and server switchover that you're going to be doing should be mountable with 0 data loss. They should all be lossless because it's an orderly switchover process during which we copy any missing log files. It's only the failover scenarios that could result in data loss here. Now, if an activated copy is mounted, everything's gone well, we've answered the question, is the database mountable? And the answer was yes. So we mounted the database, and now we have a new active copy that used to be passive, but now it's the new active copy. What happens here, though, is now it's taking off from where the old active left off. So if the last log number it got from the old one was log 6, it's now starting with log 7, then log 8, log 9, and so forth. It's continuing on. Now, if it was a lossy failover, ACL couldn't complete for whatever reason, so there were some log files that were missing. What will happen is it will request redelivery of missing messages from a component called Transport Dumpster that runs on every hub transport server inside the organization. And in fact, we made a change in 2010. The call will now be across sites if you've done a cross-site database switchover. Okay, that's a big difference from 2007, where nothing ever moved between sites. Now we have the ability for a single database to move between sites. And when we do Transport Dumpster redelivery, we request from the Transport Dumpsters in the local site and the original site as well. So any messages that would have been lost are now being recovered as a result of that. Then, once that original active database comes back on, then it will go through what we call divergence checking. It will see, is there divergence in the log stream? Is there divergence in the database pages themselves? And a feature called incremental resync will try to patch up that previous active copy and make it a viable passive copy to hopefully eliminate your need to reseed that passive copy. Now, of course, if the entire disk is gone and there's no copy to patch up, you're looking at a reseed operation. But if somebody just went and rebooted the server, and you still have a viable database, then incremental resync can just throw away the log files and then copy the new ones over. And if necessary, throw away database pages that aren't in the new active copy and then copy over good pages that the old active, which is now passive, doesn't have yet. All right. The last section that we're going to talk about is Data Center Activation Coordination Mode, DAC mode. How many of you have heard of DAC mode? Okay, so DAC mode is really primarily for site resilience. It's not going to do too much in an HA standpoint, but it's really there for site resilience scenarios, and it's really there for one specific scenario, which I'll show you at the end here. But DAC mode, it's really just a property of the DAG. You use set DAG, you turn DAC mode to DAG only, basically is what you're doing. And when you do that, that invokes a slightly different behavior mechanism for Active Manager with respect to whether or not it will mount databases on startup. Okay? So yes, Active Manager now is the gatekeeper for mounting databases, and it controls whether or not the information store will mount them. But Active Manager can't do it by itself. It needs permission. Active Manager has to get permission in order to mount databases every single time it starts up. And you'll see what I mean by that in a minute. And the reason it's there is to actually form, and I'm not sure how well I like this term, although we've been using it for years. It's meant to act as an application level form of quorum, but it's not the same type of quorum in a cluster. It's different, and I wish we hadn't used that term, but we started using it early on, and that's how we've been describing it. But basically, it's designed to prevent the active copy of any given database from being mounted in two different places. DB1 active here and active here at the same time is a split brain scenario that's going to result in data loss. So we want to prevent that in the site resilience configuration, and we do that through the use of DAC mode. And as a side effect, DAC mode also lets you use our site resilience tasks. So you can use our PowerShell commandlets to do a data center switchover and not really have to worry about using cluster tools to do that. So that's a nice side effect of there. So in RTM, we only wanted you to put DAGs that had 3 or more members and 2 or more AD sites into DAC mode. Any other DAG, we didn't want you to put in DAC mode. In SP1, all DAGs are invited to the party. All DAGs can be put into DAC mode, and so you can get the benefit of not only that application level form of quorum, but also the benefit of using those site resilience tasks. So how does DAC mode work? Well, it uses this extremely fancy protocol called the Data Center Activation Coordination Protocol. Fancy, fancy name. Fancy name that I just made up, literally, because I had to document it. And internally, when we developed this protocol, it was called the Mommy May I protocol, okay? Because it has to ask permission. And you'll see how that works again. But I can't document something called Mommy May I. That just doesn't translate very well in other languages. So we had to come up with a different name, and so I came up with the name Data Center Activation Coordination Protocol. Makes it sound way cooler than it actually is, because all it is a bit in memory that's either set to a 0 or a 1. Fancy. 0 says I can't mount databases, 1 says I can. It's not too complicated, it's pretty self-explanatory. But how does it actually work? Well, there's a startup sequence. Anytime you start the replication service, Active Manager always has that bit set to 0. And it needs to either be able to communicate with all other DAG members that are on what we call the started servers list, in other words, the ones that are up and operational. If it can communicate with all of them, it will flip its bit to 1 and start mounting its databases. If it can communicate with any other DAG member that has its bit set to 1, it will flip its bit to 1 and start mounting databases. If neither of those things are true, it can't talk to anyone that's set to 1, they're all set to 0, or it can't talk to all the servers on the started servers list, its bit stays at 0 and it does not mount databases automatically. Okay, and it's important to understand how that works. This is the one scenario for which DAC mode was developed. It may have other implications, but this is its sole purpose that I'm about to show you right now. So we've got a DAG. It's extended across multiple data centers, and we've got the WAN here. This is our primary data center, so we've got the majority of voters. In other words, 2 voters here and the witness over here. Over here, we just have 2 voters, so this is in the minority in our secondary data center. The scenario DAC mode was designed to protect you against is this scenario. You lose power in your primary data center. And of course, when you lose power in the primary data center, it takes out the WAN as well. You decide that power's going to be down for a while. I need to do a data center switchover. And so you activate, oh, excuse me. What happens, oh, I just gave it away. What happens when you lose power and you lose the WAN? I just gave it away. What happens to the other side? That's right, quorum is lost over here, and you lose that, and the entire solution comes down. So you want to start servicing these clients. You built a site resilience configuration, and you want to get those clients back up and running while the power's out. So you do a data center switchover, and you activate these members over here. You're now using an alternate witness server, and you've reestablished quorum, and life is back good over here. Now, music will not play in all cases, so thank you for that. So what happens here, you've activated this, this site of the messaging solution, and now you've restored power. Power comes up here, but the WAN is still down. This is the key element why this feature is here. The WAN is still down. Now, these three servers over here, they look and they say, oh, I can't communicate with these two, but I have 2 voters and a witness. I still have quorum. And because I have quorum, I'm going to come up and start mounting databases, right? Wrong. You don't want that to happen. You've done a switchover, and these guys over here, they know that these 2 are down, but these 2, they don't know that these 2 are now in control. They see that they have quorum, and normally they would want to go ahead and mount their databases, and in doing so, that would create a split brain scenario. But instead, what happens here is, remember that DAC-P startup bit. These are just starting up. Power just got restored. They have a DAC-P bit set to 0. They need to be able to communicate with all the servers on their started servers list, which they can't, or any other server that has a DAC-P bit set to 1, again, because the WAN is down, which they can't. So their DAC-P bits will stay at 0 and not flip to 1 until the WAN is restored, connectivity is restored, and you have all the servers happily talking to each other again, and that's how they get permission to mount the databases. That is all that DAC-P does. And that is the only scenario for which it was developed. Anything else you may have heard or read about DAC-P is probably wrong or misleading. It does not allow you to have data center failovers. It does not automate anything for you. All it does is prevent these guys from mounting the copies that are mounted over here because these guys don't know they're mounted over here. That's all it's designed to do. And in fact, it's this specific scenario, the loss of power in the primary that takes out the WAN, causing you to activate the secondary, but then bringing the primary back up without the WAN. That is the one and only scenario for which we developed DAC mode and that fancy DAC-P protocol. All right, and with that, that's it. We are out of time. But I'm happy to take any questions that you guys have off to the side after I pack up. I'd love to take them publicly, but thank you. Thank you. But I know you guys want to get to lunch too, so I just want to leave you with some resources. Feel free to check out the docs and my blog and tweet me and email me and whatnot. And again, don't forget